Okay, now let's look at example 12. Forces F1 is equal to 5.6 Newton and F2 equal to 10.3 Newton are applied tangentially to a disc with radius 36 cm and mass 5 kg as shown in figure. Calculate the net torque on the disc and the magnitude of angular acceleration of the disc, and given the moment of inertia is using this formula. Okay, so now we have a disc here. So this is the disc with radius 36 cm and then with mass 5 kg. And on each side here, kita ada forces. Force yang pertama 5.6 Newton. Force yang kedua 10.3 Newton. Okay, so first we want to find the net torque. Maksudnya jumlah torque acting on the disc. So the net torque. Okay, so first kita akan identify forces dahulu. So kita sudah dibagi force 1 dan force 2. And then since this ni dia ada mass, so dia akan ada weight force going downward. And then ada normal force going upward. Okay, so now maksudnya dekat sini kita akan cari torque for each of the force. So we have torque 1 plus torque 2 plus torque by normal force plus torque by weight force, and then equal to what? This is the value that we want. Okay, so now torque untuk normal force and weight force adalah sama dengan kosong. This will be equal to 0 because we know torque is equal to Rf sin theta. Dan sekarang ni kita punya angle of axis of rotation adalah dekat tengah-tengah. Okay, dekat tengah-tengah dia akan ada pivot point. So we have a pivot point in the middle here. So dekat pivot point, we learned before that dekat pivot point, torque will always be equal to 0. Sebab dekat sini dia punya distance, value untuk R dia adalah kosong sebab dia ngam-ngam dekat pivot point. That's why torque untuk normal dan weight adalah sama dengan kosong. So now kita tinggal T1 and T2. Torque 1 and torque 2. So let's find torque 1 first, which is equal to Rf1 sin theta. So radius still sama 36 cm. 0.36 meter. Okay, don't forget to change to meter. And then F1 5.6. And then angle dekat sini, dan dia sudah cakapkan tangentially. So meaning that it is tangent to here, 90 degree. So you will get it is equal to 2.016 Newton meter. And then the direction untuk torque 1. So since force ni ke bawah macam ni kan. So maksudnya this ni kita akan tarik dia ke bawah. So it will rotate like this. So dia akan rotate macam ni. Which is rotation dia ni adalah anti-clockwise. So anti-clockwise. Okay, let me write down first. Anti-clockwise positive. Clockwise negative. This one kamu kena sentiasa ingat ya. The direction untuk clockwise dan anti-clockwise. So this one positive, it is anti-clockwise. Okay, and then next one torque 2 sama dengan Rf2 sin theta. So value R dia still sama daripada sini ke sini. Daripada sini ke sini, which is 36 cm. Convert to meter, and then F2 is equal to 10.3. And then sin, angle adalah sama juga, 90 degree. Sama macam dekat sini lah tadi. 90 degree, so you will get 1.692 Newton meter. And then the direction. So now kita apply force ke sini. Maksudnya kita tarik disc ni ke bawah. So disc ni akan rotate like this. So it will rotate like this, which is clockwise. So kalau clockwise, dia akan jadi negatif. Okay, so now kita sudah ada T1, torque 1 and torque 2. So we can find the sum of the torque. Okay, so don't forget to include the sign as well. 2.016 minus 1.692. So kamu akan dapat okay, wait, sorry, dekat sini tersilap tadi. Actually, this one adalah 3.708. Okay, Miss tersilap tengok. So this one 3.708 untuk torque 2. So here 3.0708. So you will get negative 1.692 Newton meter. So kita dapat negatif, bermaksud dia akan rotate clockwise. Okay, so this is the first one, the net torque on the disc. Okay, next one, we want to find the magnitude of angular acceleration. So we want to find value for alpha, tapi dia minta magnitude sahaja. Okay, so in order to find alpha, so we know that the sum of the torque is equal to I alpha. So sum of the torque kita sudah dapat, which is this one here. And then alpha is what we want. Dan I, the moment of inertia, kita boleh cari menggunakan this formula. So kita sudah dibagi formula half mr squared, di mana m adalah mass of the disc, r is radius of the disc. So just masukkanlah 1/2. What is the mass of the disc? It's 5 kg. And then radius tadi 0.36 meter. So tekan calculator, you will get 0.324 kg meter square. So now boleh masukkanlah, gunakan this formula here. So negative 1.692 equal to 0.324 alpha. So you will get angular acceleration sama dengan negatif 5.22 radian per second squared. And since dia minta magnitude sahaja, okay, magnitude of angular. So maksudnya kita tidak perlu include lah negatif ni. So you leave your answer as 5.22 radian per second squared.